Hey everyone, and welcome. Today we're diving into a brand new, and I mean fresh off the presses, scientific theory that suggests a pretty wild link between the weirdness of quantum physics and, well, the world of biology. Let's see just how deep this rabbit hole goes.
It's one of the biggest, deepest mysteries in all of science. Down at the tiniest scales, reality is just a fog of possibilities, right? A haze of probabilities. But up here, where we live, if you throw a ball, it follows a nice, predictable arc. So, how does the universe make that jump from quantum fuzziness to our classical certainty?
Well, what if the answer isn't some undiscovered particle or some new fundamental law of physics we haven't found yet? What if the very thing that stabilizes our reality is life itself? That is the absolutely mind-bending idea at the core of a new paper proposing something called the transition law. Okay, so to really get our heads around this theory, we first have to appreciate the problem it's trying to solve. And it's really a story about two totally different ways of describing our universe, and the huge, mysterious gap that lies between them. Physicists have a name for it, the quantum to classical handoff. It's that moment, that process, where the bizarre rules of the quantum world somehow give way to the familiar classical rules we see and experience every single day. For about 100 years now, we've known this handoff happens, but we've never had a solid explanation for how. And this, right here, is where the new theory just gets incredibly interesting. It proposes a solution that you won't find in a particle accelerator, but in the biosphere, all around us. It's a concept called the living measurement field. So the big idea here is that the trillions upon trillions of microorganisms on Earth, the global microbiome, aren't just sitting there. The paper argues that they collectively act as a gigantic living field. And it's this field that's doing the work, performing that quantum to classical handoff, essentially measuring the quantum world and locking it into the stable state that we call reality. The theory even gives this field a fantastic operational name that's just a perfect analogy, the swarm prism. Think about it. A glass prism takes in chaotic white light and splits it out into a beautiful, ordered rainbow. Well, the idea is that this biological swarm prism takes in a whole flurry of quantum possibilities and outputs the stable, classical results our world runs on.
So, how on earth is a biological prism supposed to actually work? I mean, that sounds cool, but what's the mechanism? Well, the paper lays out a very specific four-step architecture for how this whole quantum to classical translation might really be happening.
Okay, so it starts with spin. A tiny quantum event, maybe a photon hits a molecule, flips its spin. That's the input. Then comes the signal. The local microbiome responds by releasing chemical signals. These signals then hit a gate, think of our skin or lungs, which acts as a filter. And finally, tempo. Our body's own internal rhythms, like sleep cycles, determine when those filtered signals get written into our biological state, stabilizing a classical outcome. Now, one of the most creative and, frankly, brilliant ideas in the theory is how life can pull off some really complex effects without needing delicate quantum machinery. The paper introduces a concept it calls the Mobius lever, using this fantastic analogy of an ant on a Mobius strip. And this illustrates a really key innovation. The theory proposes that some biological structures, like the folds in our gut, can have a shape, a topology, like a Mobius strip. So a chemical signal traveling along this path can actually have its phase flipped, creating interference patterns. The critical part? Life can use robust, physical geometry to precisely filter signals, a trick that in physics usually requires incredibly fragile, hard-to-maintain quantum states. It's an engineering solution. All right, now, with a theory this bold, this out there, it is just as important to understand what it isn't claiming. The authors are actually really careful to draw some very clear lines in the sand around their ideas. The paper is super clear about this. It is proposing a living measurement field, but it is not saying that consciousness collapses the wave function. It is proposing a topology lever that can sharpen signals, but this is not a theory of gravity or general relativity. And maybe most importantly, it avoids the need for that long-lived quantum coherence, which has been a huge roadblock for a lot of other quantum biology theories. So, if this idea has even a little bit of truth to it, it really does fundamentally change how we see our place in the universe, and even the very nature of observation itself. It gives us a completely new lens to look at reality. This is the philosophical core, and it's a big one. For decades, the whole observer thing in quantum mechanics has been this thorny issue, always getting tangled up with consciousness. This theory just neatly sidesteps all of that. It says the observer is the non-conscious swarm prism. This biological field does all the heavy lifting of stabilizing reality first, creating a solid classical world where complex things like brains and consciousness can evolve later on. Now, I know this might all sound like fascinating philosophy or maybe even science fiction, but the real strength of the transition law is that it isn't just a story. It's a scientific theory that makes concrete, falsifiable predictions. We can actually put it to the test. For instance, the theory predicts that a healthier, more robust microbiome should lead to a stronger translation of signals. Simple enough. It also predicts that biological responses to certain triggers should follow this consistent time lag, somewhere up to 21 days. And it predicts that those Mobius-like structures we talked about should create measurable, unique enhancements in chemical signals. These are all things we can actually go out and look for in a lab.
And it gets even more specific. Get this. The theory predicts that a 10% increase in viable microbes floating in the air should cause a measurable 1 to 3% increase in how much water your skin loses within 3 to 5 days. Now, that is an incredibly precise real-world prediction. This is where the theory moves from an abstract idea into tangible, testable science. So we're left with this one provocative final thought. For 100 years, we've been searching for a fundamental law of physics to explain the bridge between the quantum and the classical worlds. But what if we've been looking in the wrong place this whole time? What if that bridge isn't built from equations and particles, but from life itself? That's a question that could change everything.